So the problem is reachable nodes with restrictions. So we are so this is a undirected tree with n nodes labeled from 0 to n minus 1 edges. So we will be given a 2D integer array of length n minus 1 where each index is representing edges like AI. So then in AI to BI there is an index is existing. So indicates that there is an edges between AI and BI in the tree. So you are also given in the integer array restricted which restricted which represents restricted nodes. Okay, so we are given in another array which shows that these nodes are restricted. So we have to return the maximum number of nodes which we can reach from node 0 without visiting these restricted nodes. So what is given here, like in this figure, we have to start visiting from the 0 and we have these nodes like 4 and 5 as restricted. So we can't go to the 4 and we also can't go to the 5. So as we can't go to the 5, we also can't traverse 6 anyways. So here from here we can just go to 1, 2 and 3. So the maximum number of nodes that can be traversed is 0, 1, 2 and 3. So the number of nodes will be 4. Here again we know that the restricted nodes are 1, 2 and 4. Like here is given restricted nodes as 1, 2 and 4. So we can't go here, here and here. So as we can't go 2, we can go to 3 also. So we the maximum number of nodes that can be visited, that will be 0, 5 and 6. That is answer is 3. So, so it's a simple DFS problem. Like we start traversing from 0 and we will go up to what extent we can go. Like we can go up to 1. No, we can't go. So we will go back. We go back to the 2. No, we can go. So we will come back again. Again we will try to go to the towards 4, but we can go. So we will back. Here from 0 to 5 we can go. 5 to 6 we can go. So we will count it as in the our answer. So for the implementation part, we will take uh, answer as a 0, which we have to return, and we will return just answer. Yeah. One more thing, we are given the edges, so we should convert it in the adjacency list. So we are given n, and we will convert it into the adjacency list. Vector of vector int adj of n plus 1. Yeah. So what I have taken, I have taken a vector of vector int for the size and of the size n plus 1. So like the position 0 will contain all the edges where we can go from 0. Like for this example, index 0 will contain 5, comma 2, 1, comma 2, comma 4. So like there is a path from 0 to 5, from 0 to 1, from 0 to 2, from 0 to 4. So in this way we will make this adjacency list. So now we will traverse towards the all the edges for the current edges. So we can see that here in edges 0 to 1. This means that there is an edge from 0 to 1. So there is a path from 0 to 1 and 1 to path as it is indirected. So we will just make the adjacency of current of 0 dot push back uh, current of 1, and similarly adjacency of current of 1 dot push back current of 0. So now okay, oh sorry. Yeah, that's fine now. So we have now adjacency list, and another thing, we have a restricted array. Like the array can be restricted 4 and 5. So we can handle this in two ways. Like we can make a set where we can put all these restricted elements, and when we will be traversing, like we will be start traversing and we will go to 5 from 0 to 5, then we will check that whether 5 is existing in that set or not. Another way we can do, like we will make another array vector in, like we can make another array which will keep track of the restricted. So elements, this element, or we can say that blocked element of n plus 1 comma 0. So also we can, so here what we can do for auto x of restricted, and we will mark blocked of x equals to 1. So now uh, we will check in O of 1 whether the current element is blocked or not. Okay. Now we will need to just do DFS. So we will take a DFS array. Yeah. So what will be here in source? Also we need adjacency list and this blocked array. And here this is the this will be the array which will test whether the current element is blocked, I mean restricted or not. So here we will start traversing. So if blocked of source, if it is, one more thing, we will just use answer here. If blocked of source is true, then we will return from here. We can't go any more further from here. Otherwise, we can reach up to this node. Yeah, or we can say that we can traverse this current node. So we'll count, increment the answer. Now, now another thing, we need to just, as it is a tree, so we did not need to make a separate visited array. We will just use a parent. So for auto x of adj of source, like all the nodes which is connected to the source. So here I have taken parent. Why? Because uh, and in the when we are making adjacency list for the node, if there is an edge from 0 to 4, we push the in adjacency list. We, for the index 0 we kept 4, and for the 4 also, like here for the 4 also we made it, we kept the index 0. So if when we start traversing from 0 we will go to the 4, and then if we and then from when we start in traversing all the nodes which is connected to 4, then we found that there is a 0 2. So it will be a kind of infinite loop. So here we are keep tracking the parent, like the 0 is the parent of 4. So from 4, so if the, like here we can say that 2, if the node which we have to go is equals to parent, so we do not need, we will not go there, we will just continue from there. Now again we will dfs to, and now we are going to the another element like 0 to 1 and 1 to 2. So for 2, now the parent will be the current source 1. So here the parent for the next node will be the current source arj, and again blocked nodes and answer. Just, yeah, I think that's fine. You just need to call this DFS. So DFS 0, comma, -1, comma, ADJ, comma, blocked, and answer to. I will run it. Okay, we found an error. Why? Missing default argument on parameter ADJ. Uh, 1 minute. Vector of int and ADJ. It's fine, I think. Blocked answer. Vector int and ADJ. Are we missing anything? Missing default argument on parameter. Okay, so we need to just, yeah, actually it should be in the last. Like if we want to use parent, so it should be in the last. So here we will just submit and check whether it's correct or not. Yeah, it's accepted. So this is the solution for the current for this problem.